the code of conduct. We follow the code of conduct provided by Our Ladies Global. This is to ensure that we have a harassment-free environment across all our platforms, and any violation will be handled. Okay, so the session will be as follows. Yeah, definitely I have welcomed you all, and feel free and feel at home here in Kenya. I know we have been joined from people from all over the world. We are really happy that you have managed to join us. And so Dr. Laurie will be taking us through introduction to creating maps with Leaflet. I had sent you an email earlier today to have some packages installed before the session. I hope you did manage. So I'll pass the mic to Shelmith to introduce our trainer who is here with us.
Thank you. Thank you. Am I still audible?
Yes, we can hear you well.
Cool. Our trainer today is Dr. Laurie Baker, who is a visiting assistant professor of digital and computational studies at Bates College. Dr. Laurie is a disease ecologist and marine biologist by training. She earned her BSc and MSc in marine biology at the University of St. Andrews and Dalhousie University, respectively, and her doctorate in epidemiology at the University of Glasgow. Laurie is a certified RStudio instructor with a keen interest in programming, data science, and the use of novel data sources in research. The core of her research focuses on spatial and temporal patterns in human and biological systems, including disease spread, animal movement, and fisheries management. Dr. Laurie, over to you.
Thank you so much. I'll go ahead and share my screen. I'm so happy to be with all of you today. I'm joining from Maine in the US, which borders Canada and also is very close to Boston. So it's a lovely, lovely place if you ever get the chance to visit. Okay, so I just want to spend a little bit of time orienting everyone. So one of the documents that was sent out was a tutorial. So I'm just going to open up my version of the tutorial over here in RStudio Cloud. You can be opening it in RStudio. We'll just wait for the project to open. So just a short kind of orientation to RStudio. You'll be familiar with the 4 panes. So here we will have our files. So what you can do is you can go ahead and click on the leaflet tutorial.rmd file when you've opened it up in RStudio. And if you click on it, it will open up here. This is what we'll be working with for today. I've included the chunk here has the packages that will be loaded. We're going to be using tidyverse for plotting and data wrangling. We'll be using Leaflet will be the main package we use today. And that's for the interactive maps that we'll be creating. And then we've got the SF package for spatial data, R Brewer for color palettes. And then we're also using HTML tools for generating the labels later on that we'll create. And then we've also got this package called LeafSync. This will allow us to place plots side by side. And then we also have the cable extra, which is just for the table output if you want to generate the table. So all of these packages can also be installed if you don't have them already. So you'll just do install.packages, parenthesis, and then in the quotes, the package name. So you can be doing that now as I sort of go into the first part of the tutorial. To run any of the chunks, you can either press on this green sort of play button to run a current chunk, or as we get later down in the tutorial, you can also use the upside down play button to run all of the chunks above. So if you get sort of into a different part of the tutorial, you'll be able to do that there. I'm just going to open up the chat. Feel free to ask any questions there, and I'll look back at it. And without further ado, I'll get started. So this is all about introduction to leaflet mapping, and it's part of sort of a series of tutorials that I put together first when I was at the data science campus at the Office for National Statistics in the UK. And then I've since sort of updated it since I've been at Bates College in Maine. So Shell did a great job introducing me. Like she said, I did my bachelor's and master's in marine biology and then a PhD in epidemiology. And I'm a certified tidyverse instructor from RStudio. And broadly, my interests are in public health, ecology, and data science. But I generally like any question that is about data. There's some contact information down here. So I've got my personal website at lauriebaker.arbine.io. My Twitter at llbaker1707. And then also you can follow me on GitHub, which is where I put a lot of my teaching materials. So currently at Bates College, I'm teaching undergraduate students introduction to computing and programming, and also introductory data science courses. So what we'll cover today is I'm going to introduce you to the SF package, which we can use for spatial data. We'll also cover building a map using Ggplot 2, because you'll see that there's some parallels between Leaflet and also Ggplot 2 in terms of how the maps and plots are constructed. We'll briefly cover coordinate systems and geospatial objects in R, just to build an awareness that this is something you can check when you bring spatial data in. And then we'll go to building interactive maps using Leaflet, and we'll start with a chloropleth map, which we would use if we have administrative units or if we have like countries. And then we'll also look at how you can build a map if you have GPS locations. So these are just, again, the packages that we'll be using for today. And without further ado, I'll introduce you to the SF package. So the SF package actually stands for simple features. And it's a package for geospatial data manipulation and analysis that works with these kind of spatial features. So it mainly works with points. So you can have a single point, or you can have multiple points. So an example of this would be GPS locations, like say you have the capital cities, or you could have the locations of in ecology, like an animal that you've seen, or the location of buildings or anything of that nature. And then we also have lines. So we have line string and multi-line string. So you can think of lines as like roads or also sort of borders. A line is actually just a series of GPS coordinates that's then connected. So all of these sort of different types of spatial data really boil down to GPS coordinates. And then we have polygons, which will be sort of our countries and regions. And again, they're just a series of points, but they start and they can end at the same location, so that when you connect them up, they will form. And we typically will see polygons in terms of countries and regions, but you could also get national parks, marine protected areas, anything that sort of can be represented by a polygon. So for each of these types, we have the single version and then the multiple version. So a multi-polygon would be if you have like a series of countries, that would be an example of a multi-polygon. We won't be talking today about raster data, but that's another sort of common data type where you have information usually in a grid, and you'll have different sort of values for each of the grid cells. So environmental data will often come in rasters. So today what we're going to be looking at is we're going to be starting with a data set from North Carolina. And this data set is called NC, and it's already sort of included in the SF package. And we can go ahead and load in the data using a function called st_read from the SF package. And so the way that we'll do this is we can store our data in an object that we create. In this case, I've named it nc_df. And then we use the assignment arrow, and then we have st_read. And then in this case, because the file is actually within the SF package, you'll notice that we have system.file, and then we have the path name. So it's in shape/nc.shp. .shp is a really common, it's a very common type of spatial file. Often when you get something out of ArcGIS or QGIS, you'll often get a series of files, and one of them will be a .shp for a shape file. And in this case, we're also going to be specifying the package equals SF. But if you were working with your own data, you would actually just use st_read, and then you would give the path to where your spatial file is kept. And that might be in a folder, and then it will probably have the extension .shp. One common mistake that will be made is that actually when you get files out of ArcGIS or QGIS, you'll actually see multiple files, and they all need to be in the folder, although you're only referencing the .shp file. So we can go ahead and load that data in. So if you are in your tutorials now, you can scroll down to this section here, and then you can go ahead and play that, or you could also do command return on the line where it is. And you can see that it's using driver Esri shapefile. Esri is the company that produces ArcGIS. And then we have some information about the file that we have loaded. So we can already see here that it's a simple feature collection with 100 features and 14 fields. The geometry type is multi-polygon. So you'll see in a minute that each one of our polygons actually corresponds to a county in North Carolina. And then we have information about the cases of sudden infant death syndrome within those counties. We're also seeing our bounding box down here. So we can see an X-min, a Y-min, an X-max, and a Y-max. And what those are showing respectively is the latitude and longitude of our spatial area. And we'll see that in a moment when we go to plot it. Okay, so it has the number of sudden infant death syndrome cases for counties in North Carolina. And we have data from 1974 to 1978, and then from 1979 to 1984. So one of the first things I'm going to do is I'm actually going to rename our columns to country, births, and geometry. So what you'll see is that here I'm taking the data frame that I created when I read in the file. And then what we're doing is we're selecting the columns name, BIR 74, BIR 79, and then also geometry. So the way that Simple Features works is that it will use spatial information like an additional column in a data frame. This is usually in a column called geometry. And what you would have in this case, we have each row is representing a county. And then we have the number of sudden infant death syndrome cases in that county for these two different time periods. And then the geometry is showing us the polygon for that county. So you'll see in a moment that that's actually a series of points. So first, I'm just going to rename these. So I'm going to call the name column county. I'm going to call BIR 74, births 1974, and then I'm going to call BIR 79, births 1979. So that is just sort of cleaning up my data set a little bit. And then to plot the map with Ggplot, with Ggplot, the way that it creates data visualizations is that it builds them up in layers. And often whenever you're making a Ggplot, you're going to be starting it first with a call to the package Ggplot, and then you're going to be specifying your data set. So in this case, we have NC for our North Carolina data set. So it always starts with data. You can see that when we first plot it, we're not actually seeing anything. All it's doing is creating the plotting area. And the way I always think about it is that if you were to draw a plot by hand, you might actually start out sort of tracing out the area, like if you were using graph paper, and just setting up sort of where you're going to be eventually plotting the information. So we're just sort of starting it off there. Then it's going to be built in layers. So Ggplot has different geoms, which are different ways of sort of geometrically representing the data that we have. In this case, we're going to use a geom called geom_sf that works really well with the simple features package. And what you're going to see here is that just after adding this layer, each layer is added with the plus. So we've got Ggplot parenthesis NC parenthesis plus, and then geom_sf open parentheses. And you can see here that we've got our 100 counties. So remember that we had 100 rows in our data set. Each row represents a particular county. And so here we can now see that we've got the latitude and longitude, and it's ranging from 36.5 degrees north to 34 degrees north for the latitude, and then 84 degrees west to 74 degrees west for the longitude. And we can already see that we have our outline of North Carolina. You can see that there's an interesting shape at the coast. That's the Outer Banks, which I've heard is a really beautiful place. Okay, so now we have like plotted our data, and then we've also specified the geom that we want to use, but often we're going to want to be representing information on our map. So we're going to be doing this with the aesthetics layer. So with the aesthetics, what we can do is we can specify like the fill that we want. So in this case, we're going to be filling each of the counties by the number of sudden infant death syndrome cases in that area. So now you'll see that a legend has been automatically generated, and you can see that it's going from 5,000, so 0 all the way up to 20,000. And as the color gets lighter, the number of cases is actually getting higher. So we specified that within aesthetics within our geom. And the aesthetics are always going to be relating to some variable within our data set. So if we just want to change a color or change something else, we would do that outside of the aesthetics. The aesthetics really is just going to refer to a column within our data set. So in this case, we've got fill equals births 1974, and now we can see the number of sudden infant death syndrome cases in North Carolina. So already our eye is drawn to some of these lighter blue counties, which have a higher number of cases. The next thing that we'll want to do is we'll want to add some labels. So we can do that with another layer called labs. And then here we can now specify a title, x-axis label, a y-axis label, and a fill. So in this case, I've used the title SIDS cases per county. So I've used SIDS cases per county, and then we have the longitude and also the latitude. So I've done per county in 1974 to 1978, and then I've got the longitude, latitude, and then the fill number of SIDS cases. So what we can see is we can see those changes now reflected on our map. So now we've got the latitude and we've got the longitude. Our legend now has the number of SIDS cases that we specified over here for the fill. And then we also have a title that we've added to our map. So this is one way to create a map using Ggplot 2. The last thing that we would like to add is to change the scales. So if we go back to the previous map, you can see that the latitude, it feels like a little bit squished. So you can also use the scales layer if you want to change any of your axes, like for the number of breaks that they have. And the way that the scales work is you'll have scale and then you'll specify the variable that you're talking about. So in this case, because we want to change the y-axis, we've got scale underscore y underscore continuous. So the reason it's continuous is because we're doing numbers from 34 up to 36. And then what we can do is we can manually specify the breaks. In this case, I'm doing 34:36. That's going to generate the numbers 34, 35, and 36 for me. So then we get the 36 degrees north, 35 degrees north, and the 34 degrees north. So there's different ways to customize your plots as well. So one of the things I want you to remember from this slide is that what we're going to be doing in Leaflet is very similar. We're going to be building up our map in layers, and we're going to be making decisions about what we want the fill of our map to be. And then we're going to be looking at sort of different ways to customize it by adding labels, by adding, changing different aspects. So I want to talk a little bit about coordinate reference systems. So every location on Earth is specified by a longitude and a latitude. So for instance, I don't actually know the longitude of where I am in Maine, but I know that the latitude is about 42. When I was in Glasgow, the latitude was 55. So I'm very happy to be in a slightly more southerly location so that winters aren't so dark. But each of you will be sort of at a different longitude and latitude depending on where you are in the world. This coordinate reference system is going to determine how the data will be projected onto a map. So a good way to think about this is if you think about the world, which is a sphere, as like an orange. When you peel an orange, it's very difficult to peel it and then lay it flat. So what coordinate reference systems do is that they make different decisions about how to represent countries, and they'll often be distorted depending on what sort of decisions are made, because it's very difficult to sort of lay the world flat. So these are just a few different coordinate reference systems that are used. So we've got here like the Eckert first, Good, Homoson, Vander, Grinton, Miller, several different ones. And you can just see that we've got the same sort of map of the world, but you can see that different parts of it are sort of skewed in different ways depending on how it's being projected. And this becomes important mainly when we're when we bring in a spatial data object into R, we're going to want to know sort of what coordinate system it was created with, so that then we can make sort of decisions about how we'd like to plot and represent the data. Fortunately, the image hasn't showed up on this slide, but I wanted to show you a really interesting website called The True Size Of. So this just allows you to pick a country. So in this case, because we're looking at Our Lady's Nairobi, here we've got Kenya. So Kenya, total size in square kilometers is 580,367. And what we can do is we can take the country Kenya and we can actually drag it down. So if we put Kenya down here, you'll notice that Kenya is right on the equator. So this is sort of its size, but as we move it up to somewhere like Greenland, you can see how that size of the country changes. So I showed this to my mom just the other day, and she got very confused because she was like, how is the country size changing? Isn't it always the same? And what's happening is that the country stayed exactly the same size. The only thing that's changed here is that the projection that we're using it really distorts things depending on where it's located on the map. So what's really fascinating about this is you look at a country like Greenland, which just looks huge. And then if you move Kenya up here, I mean, Kenya is maybe representing like a half of the space. And the neat thing, we can choose some other ones. So somebody said that they were from Bolivia. So we can go ahead and put Bolivia in there. So here we have Bolivia in South America. We can again sort of drag this up, and then we can compare it to sort of some other way. So here I am in Maine in the US. So if you were to put Bolivia sort of in here, it's sort of the size of several US states. Or if we were to move it over to Europe, it's actually like, you know, maybe like half or a third of Europe. If we move it up to over here to Greenland, you can see it's very large, and actually in square kilometers, it's 1,098,581. So it actually is larger than, remember, Kenya was 580,367. So you can really see that, you know, the size of things can be very, very skewed where they are in the map. And so you might enjoy sort of going to this, it's the truesize.com, but you might enjoy going to this and just seeing sort of actually how big is your country. We can also do the reverse. So let's say if we were to take, why don't we take Canada? So we can go ahead and take Canada. Canada is very large because it's got, you know, the Northwest Passages and all of these islands. But if we were to sort of move it, if we were to bring it down to over here to Africa, you can see that it's maybe like a third. So the total size in kilometers squared is 9,984,670. So it is about 10 times the size of Bolivia, but still, if you bring it down to closer to the equator, you're going to notice that it sort of shrinks a lot in size. And then as we move it away from the equator, it's also sort of distorting. And what's interesting too is that this distortion is not just in the size, it's also in the shape. So we can really see how our the particular coordinate reference system that we choose can really sort of change how things appear. So one of the ways we can check for the coordinate reference system is we can use this function called st_CRS, which just stands for coordinate reference system, from the simple features package. So we can do st_CRS and then NC for our data set on North Carolina. And then here we can see that there's a lot of information, and actually coordinate reference systems, when you get into them, are very, very complex. And they can be represented in different ways. But some of the information we can pick out here is we've got a datum. So it says North America datum of 1927. It tells us also primum is Greenwich. So Greenwich in London, that's where we have our the longitude sort of set to 0. So we use that as sort of a reference point there. And then we're seeing some other information down here as well. So it's important we can sort of check the coordinate reference system. We can then sort of Google, find out sort of what it represents for each case. But often what we want to do is we just want to transform our coordinate reference system so that it's either easier to plot, or there's also different coordinate reference systems that can be more easy to do calculations with. So if I wanted to calculate the distance between Maine and Nairobi, I might choose sort of a different coordinate reference system depending on what I was doing. So we can transform a coordinate reference system using the st_transform function. And it's tricky sometimes to know like what a sensible coordinate reference system is to assign. In this case, because we're going to be creating our map in Leaflet, there's a particular reference system that Leaflet works with, and that's most compatible with some of the base maps that it uses. So if we're going to make the plot using Leaflet, we can use EPSG 4326. And the way that we do this is we do st_transform open parentheses, and then NC, which is our data set, comma, and then we've got in quotes plus init equals EPSG colon 4326. And then we can check our coordinate reference system again using st_CRS. And we can see the coordinate reference system. It's been defined by user input, which is ourselves. And we've got EPSG 4326. And you'll often see a really common projection that's used is this World Geodetic System 1984, which often is called like WGS 84. This is a really common coordinate reference system that's often used. They're moving sort of more and more towards this WKT coordinate reference system, which I believe stands for like well-known text. There's a lot more information about it in the SF package, but I think that one of the things, if you're new to sort of spatial data, is just that you can sort of start to like look at the coordinate reference systems, and then also you can sort of find out about different ones, and you can always take sort of EPSG and then 4326 and take a look at it. Again, the reason why it can be so complex is because line that sort of orange flat is very difficult. So different decisions are being made. We can also see here that the length unit that's being used is the meter. So again, depending on maybe what kind of calculation you're doing or what sort of system of measurements is being used, you may sort of want to calculate things in terms of kilometers, in terms of miles. You can convert between the two, but that's sort of one thing that also can come into play. So what we've done here is we've transformed a coordinate reference system. Now we're all set to create our first leaflet map. So Leaflet is one of the most popular open source JavaScript libraries for creating interactive maps. And like Ggplot 2, it's also built in layers on top of a base map. So one of the things that Leaflet provides is a set of base maps, but there's also these different provider tiles that we'll see in a moment. And what gives it the interactivity is this JavaScript that's happening underneath. So both different languages like Python and R have their own ways of sort of using these packages so that you get the interactivity, but you can also stay in a familiar language like R to use it. So just like our Ggplot 2 map, every plot starts with leaflet. So here we've got leaflet, we're specifying our data set. So in this case, we've got data equals NC. Just like before, we're seeing a blank sort of canvas. This is going to be where we're eventually making our plot, but first we need to specify our spatial information. So we add layers in this case using the pipe symbol. So it's a percentage sign, greater than sign, and then a percentage sign. And what we're going to be doing is just like in this case, so we're going to be adding tiles. This is going to provide our base map. So here we've got add tiles, open parenthesis, close parenthesis. You'll notice that there's a slightly different syntax compared to Ggplot. So here we're using, I think this is camel case, so starting lowercase, and then the second word is going to be uppercase. So here we've got add tiles. You can see now that we've got a background of the world, and we've got the world repeated over multiple times. It's already interactive, so we can zoom it in, and we can see sort of over here Kenya, and then we can also see sort of over here like Libya, and you can get sort of more and more detailed as you zoom in onto places. So here we are in Maine. Currently I am in Portland, Maine. So just this location here. Maine also has a very lovely coastline. So if you like the ocean like me, then it's a lovely place to be. I think we also had somebody in Edinburgh. So we can zoom in over here as well. So one of the nice things about Leaflet is that we already have this interactivity built in. We've just added our first base map using add tiles. We're not yet showing any of our data. That's going to come in a minute, but already someone can be sort of zooming in, exploring, seeing our map as we create it. So just to remind you that layers are going to be added with the pipe symbol in Leaflet, whereas in Ggplot they're added in the plus. And it's a little confusing because the pipe symbol is also very heavily used in the tidyverse packages. And so it's the same symbol, but different. In this case, it's more of that sort of adding a layer. Okay, so we've added our tiles. Next, we're going to want to be setting our view. So the way that we can do this is that we can put in another layer, and then we're going to use the, in this case, the function sort of set view with a capital V. And then here we've got LNG is for longitude. I'm going to set it to sort of minus 80. What I'm specifying here is like the center point. So I'm going to specify the longitude to be minus 80 and then the latitude to be 34.5. And then you can also set the zoom. So in this case, the zoom is equal to 5. We can sort of zoom in and out from there, but you can see that we've got here North Carolina, and then we've got the surrounding states. So I want to give you guys a couple minutes to play around. So try setting the longitude to 38 and the latitude to 1. And then try setting different values between 0 and 10 for the zoom. And you can see what you get. So I'll give you guys a couple minutes to do it. And then if you want to write in the chat what location that takes you to, and that'd be great. So I'll give everyone a few minutes. And if you want to write in the chat when you've like what location that takes you to. And I'll also get the links to the material. So this is the links to the slide. We're on slide 31. And then the link to the material, if you go to this page, it'll then link you down. You go to the bottom of the README, you'll be able to click on the tutorial to download. Yeah, great. So Njoki has already looked at it. So if we set longitude to 38 and latitude to 1, so I can go into my tutorial here. Yeah, exactly, Fiona. And I'm one of these people that if I ever get a tattoo, it'll be a tattoo of sort of which one's latitude and which one's longitude, because whenever there's two things, I find it very easy to get confused. So I'm just going to be scrolling down here to that location in the leaflet map. And did anyone try out different levels of the zoom? So let's go ahead. I'm going to run everything above here. And then I'm going to run my current chunk. Okay, and then I wanted to change longitude to 38, and then latitude to 1. And if I go ahead and run that. So one way to think about it is that latitude is going to be moving you up and down. So remember that Kenya was very close to the equator. So the latitude would be 1. And then the longitude is going to be moving you across. Because the Greenwich Meridian line is in the UK, it means that anything to the east of London is going to be sort of positive value for longitude. Anything to the west of London is going to be a negative longitude. So remember when we were in North Carolina, we were like at -80. Now, if we're going sort of to Kenya, we're actually sort of moving west of London. And then the same thing goes with the southern hemisphere. So if we were looking at a location within Bolivia, then the latitude would be negative as we're moving more away from the equator. And then also the longitude would be negative because we're moving away. All right, so great. We can already see Kenya, and we're also seeing a little bit of Tanzania and also Uganda and also Somalia. So here we've got Nairobi. So one of the things that you're going to be wanting to think about when you make a map is what kind of context, what location do you want to show? And that's where the set view is going to be important. So if we change, let's go ahead and change our zoom. So you can see that we've zoomed in. We can see in this case sort of Meru and Samburu. So we can sort of zoom out again a little bit. It kind of depends. If you were showing locations that are right within Nairobi, then you would probably want to go to a zoom of like 10 because you're going to want to be in the capital city and showing that. Whereas if you're going to be showing sort of information more for the region of East Africa as a whole, then you might sort of choose to zoom out like a little bit more. And that can just be set by where you set the zoom to be. The longitude and latitude you specify is going to be specifying the center point. The way that I always will do it is I'll actually go to Google Maps and you can click on a location and then you can see what the latitude and longitude is. So that's also a helpful way to think about sort of where you want to put things. And we're going to be looking in a minute at how we can change some of these base maps so that we can provide more meaningful context. Super. So that's going to take us over to Kenya. In this case, I've got a zoom of 6. And you can be exploring. The nice thing is that when you share a map with someone, they're going to be able to explore and like look in the area like on their own. The next thing we might want to do is we can add provider tiles to give different base maps. So you'll notice like a difference between this one just had the base sort of tile map, which I believe is for OpenStreetMap. So if we were to zoom in even more to North Carolina and we could look at like Raleigh, we can go a lot more in depth there. And you'll notice that as we get sort of more and more into the city, we can also see more features. So what you will notice is there's going to be a point where we can't sort of go further, or sometimes where it will blur out. But we can see here, for instance, like where a city cemetery is. We've got different symbols here for where there's churches, where there's parks, where the middle school is. You can see that everything's kind of organized very much in kind of a grid pattern, but we can also see where some of the roads are and other sort of details. So another nice thing about these base maps is that they can give a lot of context. So if we want to add a different type of base map, the way we do this, instead of add tiles, we now have add provider tiles. And here you can see that, oops, it's always very sensitive. Okay, so in this case, we're using providers $stamen.terrain. What you can see is that this is giving us a little bit more of a terrain map. So for instance, if we were to zoom in here, you're actually seeing where there's different mountains. So we have Mount Washington, 1,917 meters. Mount Katahdin, that's the end of the Appalachian Mountain Trail in Maine. We can see that's at 1,606 meters. We could go over. I know that in Kenya there's Mount Kenya, which I would love to climb at some point, but we can go in sort of here. So we can see like Mount Kenya is 5,199 meters. We can see over here we've got Mount Kilimanjaro, which is 5,895. And we've also got, we should have like Mount Meru around as well. I think would be right here. You can see that this layer, we can't sort of zoom in quite as much, but what you can really see is that we're able to sort of start to see some of the different sort of like terrain features. So we can see where there's more of the mountains and other peaks. So the way that we can choose different base maps is that we can specify so providers $, and then the name of the provider tile. So if you want to find out like which provider tiles you can specify, you can do providers $, and then if you click the tab key, it's going to come up with all the different options that you can take a look at. So if I go over here, and feel free to sort of do this in your own sort of setting. So for instance, I can go into here. So I've got add provider tiles, providers $. I'm just clicking my tab key. I can see now all of the different provider tiles that I can use. So one of the things is that some of these you will require sort of like an API in order to use them, and not all of them are free. But let's say, for instance, you'll notice that there's terrain background, there's also terrain labels. So sometimes you might actually add multiple provider tiles, and that's because you may want a certain set of labels included. I know that most of the Esri sort of background provider tiles work. I really like the ocean base map because I studied marine biology. So you can go to the $, press the tab key, and then you can see the options, and then you can choose one. Now, if we go ahead and run this again, you're going to see that we have this really great ocean base map tile. So you can see sort of like the drop off of like the ocean shelf here. Let's see what it looks like. And yeah, so and it shows really cool things like the Mid-Atlantic Ridge, which is one of the deepest parts of the ocean. It's also showing you how deep it is. So here we've got like 757,598 meters in depth. There's a lot of sort of interesting bits. And sometimes it's hard to scroll. So let's go up here and then go over. And we can see sort of what we have off of Kenya. So we've got like the Somali Basin. You can see the Mascarene Plateau. We've also got the Mid-Indian Ridge. The deepest part of the ocean is over in the Mariana Trench, which is off of kind of in the Pacific Ocean. So you can see there's like 9,239 meters depth, which is pretty incredible if you think of, so this is the Mariana Trench just here, which is the deepest part of the ocean. But some really, really incredible things. So it's just fun to explore around. But I'll give you a couple minutes, try out a different base map. So we can go ahead and just remember, you can click the tab and then choose one you want to take a look at. I think the main thing is that when you're choosing a base map for your provider tiles, you're wanting to think about sort of like what context is important here. So for instance, I would maybe choose like an ocean base map if I was showing like maybe something about like habitat of like seals or habitat of whales, in which case sometimes the depth can be really important, because depending on what sort of species it's eating, you would sort of find those in different places or different depths. So you'll want to be thinking about sort of what context. If you're working in sort of more of like a business context, then it might be more useful to provide one with like OpenStreetMap, which then will let you see sort of like the businesses and other things. So we've got like OpenStreetMap. You have different layers. We can try the French one. So for instance, here, if I was presenting this in France, you can actually see that it's changed like the names. So it's calling like North Carolina, like Caroline du Nord. And presumably also if we go over to France, yeah, so they've got all of the names that have been in French. So it can be a good idea to sort of include this. Yeah, so Noelia tried the open weather map in the providers list, but it doesn't work. Unfortunately, there's some that don't actually open up, and I think some of those you'll either have to like download or use an API to be able to access. And it'd be nice if they made it a little clearer, like which ones are kind of free and available. But yeah, we encountered that as well when we were exploring some of the different ones. I definitely know that all the Stamen ones are usually available. TomTom, I'm not sure about. Esri as well. It might be that the open weather maps are not there, but what I would suggest is if you went to there, if you sort of search like provider tiles and then open weather map, there would probably be some good advice in terms of how to actually access those. I'm not sure if the here ones work. We could try. We could go and see if those work. What other ones have, oh, this is cool. What other ones have people tried that that they like the look of? Some of it is just a little bit of kind of trial and error. Cool. So moving along. So note that also the different provider tiles come with different licensing. So you want to check that as well. It doesn't usually matter if you're just sort of using it in an informal context, but say if you were featuring it on a website or maybe using it for like a business client, then the licensing would be something that you want to be aware of and look into. But there's a lot of sort of like possibilities that we can do. So all of those are just for the base. For the base. So Javascript, how do you manage an API? So that's a really good question. I actually haven't used, I know that you access them through an API, but I'm not sure. I think for the API, what you would do is you would almost set up an account with them, which often you can do like a free account that allows you sort of so much access. But say if you were providing like a website and then you had a lot of hits to it, they might have sort of different tiers depending on what it is. But generally what you would do for the API is you would have your sort of access, like your kind of password to your account that you access it with, and you would include that when you're loading it in, and you would have like a line of code that would sort of access the API to that particular provider tile, and then would show it. But it's actually sort of an area that I'm a little bit less familiar with, probably because I always go with the kind of free options. Cool, excellent, Marcella, that looks really, really neat. You get the error operators invalid for atomic vectors. So I think one thing that I'm noticing, Marcelo, is it doesn't seem to have your pipe. Is your pipe in there to connect all the layers? Because that could be sort of one of the parts. It needs to be sort of built up with that sort of pipe symbol so that the layers build. Otherwise, it might be seeing the add provider tiles kind of independent instead of sort of building on Leaflet, would be my guess. Cool, you're welcome. Great, so we can include different provider tiles. So, but next we actually want to be sort of, there's a lot of cool things in Leaflet, but we do want to plot our own data. So just like with our geomes in Ggplot, there's kind of a set of geomes in Leaflet as well. So the ones that we're going to use today is to plot the administrative units. We're going to use add polygons. And you can see that that's now added the outline of the different locations in our data set. So now we're showing all kind of 100 of the counties. And so add polygons, it's kind of hidden, but because our North Carolina, our NC data set has this column called geometry, that's really what Leaflet is using. It's sort of finding that geometry, it's finding those polygons. And so then when we call add polygons, it's able to plot the locations of those counties on the map. So we can do that using add polygons, just the same way that we did sort of geom underscore SF. But we're probably going to want to customize those a little bit. So we'll want to remember that our data set has son and infant death syndrome cases in North Carolina. So we are going to want to customize these so that it will show that information for us. So in order to kind of show that information and also create the fill, we might want to think about sort of what color palette we want to use to show that information. So when we're choosing a color palette, we want to think about a couple of things. So we want to think about like, what type of variable are we showing? Is it numerical or is it categorical? So for instance, a categorical variable could be, I could look at those counties in North Carolina and I could say, did they vote Republican or Democrat? That would be an example of a category. Or I could look at, in this case, we're dealing with a numerical variable because we're looking at the number of sudden infant death syndrome cases. So whereas like with something like Republican and Democrat, you can't really say sort of that like one is double the other or one is sort of higher than the other. With a numerical variable, we can actually use that information to say like, you know, this area has more cases, this area has less cases. So some of the decisions we're going to make is going to be based on that. And we have to be just careful as well when we choose things not to be sort of misleading people. So this color Brewer 2.0, I'll have the link in a second. This is a really nice one for exploring and looking at sort of different colors, and you can see sort of what they look on a map. So you'll notice it's a little bit small in this image, but here we've got, you can choose like whether it's a sequential palette, which we'll see in a moment, diverging or qualitative. You can choose the number of data classes. So if I was looking just at like Republican and Democrat, then I would only have two data classes. If I am looking at number of sudden infant death syndrome cases, then that's going to be sort of a much, I can sort of create like the number of data classes depending on if I want to show like 0 to 5,000, 5,000 to 10,000, etc. The other things that you can do here, which is really nice, is you can choose only colorblind safe palettes. You can choose ones that are print friendly, photocopy safe. You can also add context. So you could add like, in this case, we've got like the borders of the administrative units. You could see what it looks like with cities. You could see what it looks like with roads. You could try a different background, like solid color or terrain. So a lot of like these things are just sort of helping you to sort of see, you know, is this map readable? Is it showing the information that I'd like to show? And then what it gives you is that for each one of these colors, we actually get a hex sort of code for it. And the thing about colors is that if we're actually looking at a color image, it really has red, green, and blue levels. And those values can be between like 0 to 250 or 1 to 256. So 1 would be like black, 256 would be kind of going up to white or lighter. And a hex is just a different way of representing that like red, green, and blue color. And we want to be thinking about like what story are we telling with our data. So that's going to influence. So for instance, if we were looking at the sudden infant death center cases in North Carolina, there might actually be sort of a level above which, you know, the cases are extremely high, and we might want to sort of like just be looking at sort of like which counties have the highest cases that maybe would need health support or like a health information program. Or it could be dictated by like our budget, like maybe we only have money to support 10 counties. So then we would want to sort of look at like what the top 10 counties are and then show those on the map. A lot of it just depends on like what the context is, what we are going to be sort of looking at. So to choose our colors, we've got this color brewer2.org, which is really useful. Another one I've included here is there's colorcodepicker.com, which is kind of nice because say if you had a map and you wanted to match it to like a business's colors or like a sports team's colors or those kind of things, the color code picker, you can actually find out like what color code matches up to that. And then that would be something that you can provide. So these are extremely useful, especially if we want to define our color scale manually. But what we're going to look at is we're going to look at a couple sort of built-in palettes within R. So we're going to look at the R color Brewer, which is just one of the options for color palettes. So it includes sequential color palettes. So for instance, if we were wanting to look at like the number of people, and if we do display.brewer.all type equals SEQ, then what you can see here is we can see like this is like yellow, orange, red. We've got red to purple. We've got grays, greens, blues. So depending on sort of how you would like to show the information, this is showing you like the range of different colors that we could use. And we can specify these. I'll show you in a minute. We can specify these by the name. We can also use diverging. So diverging would be a good one if we were wanting to say like, you know, which counties number of cases are like above normal, which ones are sort of like below the average. So in that case, we might want to have like, you know, right where the average is as sort of a lighter color and then show sort of gradually like what's above or below. This could also be something like, you know, a good example would be like temperature, like what areas are like above average temperature, below average temperature compared to the previous year. When we're using a diverging color palette, we're really trying to sort of specify the differences. And in that case, we're probably going to be using something that's going to be centered on 0 or centered on an average or a median or a certain value. So some of the ones that we have for options here is like spectral. There's like red, yellow, green, which goes from red up to green. We've got red to gray, brown to that one's sort of maybe brown to blue green. So we have some different options here that we can use. But in order to define a color palette, we need to look at the data that we have. So for instance, if we were to look at our two variables, births from 1974 to 1978, and then births from 1979 to 1984, if we just use summary in R, we can see that like the minimum number of SIDS cases was 248. The maximum was 21,588 for 1974 to 1978. And then we can see that from 1979 to 1984, 319 was our minimum, 30,757 was our maximum. But you can also see that the third quartile in both cases is going to about either 4,000 or 5,000. So that means that 75% of our data is actually less than 5,000 or less than 4,000. So again, it depends like what we're wanting to show here. If we just want to show the cases that are really at the upper end, then we could use the function seq, which is just going to be generating numbers from a start to a stop. And then our third argument here is going to be by. So what this is doing in this case, we've got bins, we're using the assignment arrow, and then we've got generating the numbers 0 to 35,000 going up by 5,000. So this would be sort of one way we could classify our data into different color categories. So in this case, because I would just want to highlight set of the counties that are really like much higher, like above 5,000, I'm choosing to sort of create a sequence like this, but it really depends on the question. Okay, so in order to create the palettes, we can use the function color bin from our color Brewer. In this case, I'm going with like orange and red. And then our domain here is going to be our actual data. And then I'm going to have the bins equal the bins that I defined. And I'm doing that for like the palette for 74 and also the palette for 79. These are just sort of names that we're giving them. Yeah, so why is bin saved as a value instead of as a variable? You could actually sort of add it in there. This bins here is just going to give us a sequence of 0 to 35,000 going up by 500. And it's just providing the sort of categories that we're looking at. And what that's going to do is it's going to give us discrete color for each of those bins, which is going to be getting sort of gradually darker. In this case, like orange is going to be a lower number of cases. Like as it gets darker red, it's going to be a higher number of cases. It really depends how you want to do it. You can either do it in this sort of discrete way, or you could show like more of a continuum. It's up to you. And then the only reason why we specify it here is because what's happening is that our variable that's coming in is going to be the actual like births. And from that, we're going to be able to then like I'll show you in a minute, but we're going to be able to get like a color sort of match for each value. So it's going to be looking through each row in our data set in that column, and it's going to say, okay, this number of cases in this county was like 700, therefore it's going to get this color. So I'll show you in a minute, but there's a couple different ways that you could sort of set it up. Yeah, and how does RStudio know to save it as a value? Yeah, so it's an assignment, but it's actually going to have several values. So what we can do is we can go ahead and look in here. That's where we've added the polygons. Okay, so So if we go down here, we've got that. And then if we wanted to look at what bins looks like, just move this out. Okay, and we're gonna move the console there. So if I wanted to take a look at what bins look like, you can see now it's got like 0 to 5,000. So it's showing sort of like a series of values. And then in the next bit, so we're defining these color palettes. What's interesting is that when we look at PAL 74, it's actually like a function that we're defining. So it's a function and what it's going to be doing. So when we make this, so if we were just to run PAL 74 and then we pass in our data set, you're going to see we have 100 values. So one for each county. And if we were to put, we could actually save that as like a color column. So for instance, I could do something like NC, and then I could do mutate to make a new column, and I could do colors equals PAL 74, and maybe I'll call this colors underscore 74. We could do PAL 74 and then verse 1974. And then we can take a look at what that looks like, colors 74. And we could do colors 74 and then verse 1974. So what I'm doing is I'm just selecting out those two columns. Now what you can see here is we've got the color. So this one is less than 5,000, 1091. So it's got this color, which is going to be the hex, but it's going to be sort of an orangey color. And you can see actually that like all of these have the same value because they're less than 5,000. So what that is doing is we're creating a function to then sort of classify and assign the color to it. So to give you an example of then what that looks like, so we can now specify more things within the add polygons. So one of them is we can do like put the palette. So whenever you see this like tilde, it kind of means that it's going to be like a function or something that's being applied there. And then you can see it's got the birth. So we've got NC birth 1974. And then there's a few other things that we're doing here. So this is just for the fill color. You can see now that we've got each county has sort of like a different color. I've still got my ocean base map here, but we can sort of be zooming in and seeing these areas. So that's what's giving us our color is we've made that color palette, we're assigning it there. The other things that I've specified here is the fill opacity. That's like how transparent each of these are. And the thing is that transparency is going to depend on like, are you going to want to show a little bit of your base map underneath the color or not? The other thing that we've got here is color is like white for the borders. Then we have the opacity for that border is 1. So 0 would be fully transparent. 1 is going to be a solid color. And then we've also got the weight of that line is 2. So that's showing us like the size. If we go on to the next slide, you'll notice that I've now changed it to fill opacity is 1. So we're not seeing any of the base map underneath. I've changed the border color to blue. I've changed the opacity of the border to 0.7. You can't really see it sort of that well, but it would be sort of a little bit see-through. And then I've also changed the weight to 1. So if we just go back sort of between that, you can see the border was a little bit thicker. It was white. It was sort of fully there. And then this one, it's sort of like less. So I'm going to give you guys a chance to play around. So try picking some different values for the color, opacity, and also the weight. And see what you come up with. For the color, you can put in quotes any sort of like color you can think of. So it could be like red, yellow, orange, purple. Probably if you look into the documentation, you could find some other colors that you could specify there, and then try sort of playing around with that fill opacity and also the weight. And if you want to put in the chat sort of what you've been trying, then that'd be great. Remember that the opacity is just going to go between 1 and 0, but you can try to lighten it up. Isabella, that's a good question. If there's a leaflet integration form with QGIS. So there is, in the sense that any, you can save anything that you've created in QGIS out. So if you wanted to like save a shapefile or something else out of QGIS, you could then just read that into Leaflet using like calling that shapefile. So in that way, you can sort of download things out of QGIS and then bring them in. And you can also use it to like generate like the GPS locations or other things. I don't know if there's anything, and I know that you can, there is an integration between QGIS and R. So in which case you could just like, you know, have within your script some of the QGIS stuff and then the other pieces. There could be more, but I don't know sort of for sure, but generally like anything that you can sort of download out or have like a spatial information. Yeah, so how to load the shapefile, and then you can use the leaflet for formatting and HTML parsing, exactly. And for how to load the shapefile, if we go sort of up here, so when you're reading in a shapefile, which could be from QGIS or ArcGIS, the way that you're going to do this is you're going to use the st_read function in the SF package. This system.file is just because we're calling something from within the SF package. So what you would do is you would ignore that, and then you would just give it the path to your shapefile and all the other sort of QGIS files. And then you could read that in to sort of where you would want. Yeah, you're welcome. Excellent. So, okay, so we've been able to sort of like generate the fill for those colors, and we've changed some of the different elements. So if we ever want to find out, I always tell my students, I don't remember anything off the top of my head, but I do remember how to search for things within R and outside. So if you want to look at what you want to change and find out more about it, you can use the question mark and then add polygons with the open parentheses. And then that's going to take you to the documentation page where you can see that color is referring to the stroke color, so that border. Weight is referring to the stroke width in pixels. And opacity is the stroke opacity, and then fill color is the fill color, fill opacity is the fill opacity. So you can find out what things you can change. If you do question mark add polygons, then you'll also see that there's highlight options. So there's options for highlighting the shape on the mouse over. So again, one of the nice things about working in Leaflet is that we have this like interactivity, and so we can provide something for the user so that they kind of feel like they're interacting with the data. So we're going to look at highlight options next. So a way to do this, just like within Ggplot, we can actually assign our plot to an object. So for instance, I can have this first part of my, just where I'm loading the data, adding the background provider tiles, and then setting the view. I can actually save that in a new object called M1 using the assignment arrow. And then I can then build on that with sort of more layers. So I'm doing this partly because now we're running out of room on the slides. But it is helpful for if you want to sort of try out some different things, but you know that like, okay, I do want these base things and those are going to stay the same no matter what. So I've saved this into M1. And then in the next part, I'm doing M1, and then I'm adding the polygons. So I'm adding that. So we're where we were before, but now all of this is sort of saved within M1. So then the next one I'm going to do is I'm going to add these highlight options. So I'm going to do highlight equals, and then we've got highlight options. You can see we've got highlight options, and then I'm specifying a new weight, a new color, a new fill opacity, and then also bring to front equals true. So now what that's doing is it's going to mean that when I highlight over a particular county, you can see that it's changing. So my border is changing to be blue. You can see that the thickness of that border is increasing because I put the weight to 3. The fill opacity is changing also. It's now solid. It's no longer see-through. And it's also bringing it to the front. So you feel like it's sort of popping out of you. And this is really helpful because then if you're sort of talking about a particular county, you can sort of see that you're hovering over it. And the nice thing is this works sort of also when you zoom into the location. And the highlight options are exactly the same arguments as what we were using for the add polygons. The only difference is that now it's getting stored into its own argument of the highlight. So that can be particularly useful, and a nice way to sort of bring in some of the more of the interactivity that we would like. Great. So I see the questions about data sets. I'll get to those at the end because that's a great question. So we've had, we've shown how sort of we can highlight things, but the other thing that we'd like to add is some labels. So ideally, when I click on a particular county, I also want to be seeing the information. So I want to be seeing how many cases of sudden infant death syndrome that they have. So the way we can do this is we can add labels, and the labels are going to be added using HTML. And the function that we're going to be using is one called sprintf. So it returns a character vector containing a formatted combination of text and variable values. So here we're going to be creating a new object called labels with our assignment arrow, and then we have sprintf, and then open parentheses, and then in quotes we've got the less than symbol strong greater than symbol, and then we've got %s, and we've got the less than symbol, a slash, and then we've got strong, and then we've got the greater than symbol, less than symbol, BR slash less than greater than symbol, %G verse. So this looks like very hard to follow, but we're going to break down what each of those elements are. So we've got that first part, that's sort of setting the appearance. So it's setting the HTML appearance of the labels. We're then specifying our county. So that's going to be, remember, the column that has the county name. And then we've got the births from 1974 in another column. And then we're going to be piping that into the lapply HTML tools, : HTML. That's just going to change, kind of put this all together and make those HTML tools. So that then when we look at our labels, you can see that we have strong, and then we've got ash. That's going to be one of our first county name. And then we've got 191 births. So let's break that down a little bit. So one thing is that HTML, it's a markup language for the web. So strong just means bold. And then the less than sign, BR / greater than sign, that means like a new line. So in this case, for my labels, I want to have like county name and I want it to be bolded. And then on a new line, I want to put like the number of births that are there, and I'm not going to bold them. The other part of this you're seeing is PHP, which is another language, and it's for hypertext preprocessor. So the %s is a placeholder for a character string. So now remember that our NC $county, that contains the names of our counties, and those are character strings. So it's, it's a word that we're using. So that's just a placeholder. So that just means that all of my county names are going to be bolded. And then the %G is going to be a general format placeholder for a number. So again, what that's going to do is that's going to insert my North Carolina births from 1974 to 1978 column. And that is going to be plugging in. So in this case, Ashe County had 194 SIDS cases for that. So there's a number of sort of pieces there. And the important things to think about is sort of what do you want in your labels? What do you want the appearance to be? You'll then maybe want to just cross-reference with sort of HTML, how you can make something bold or how you can make something italic. And you can include that. And then the other bit is sort of, okay, what type of variable? Is it a string? In which case I'd use %s. Is it a numeric variable? In which case I'd use %g. Do I want any other text in there? So in that case, I'm putting like births to give like the text. I should probably update this so that it has SIDS cases instead of births. But this would be how we're then creating our labels. And because we're using the lapply, we're actually generating a label. So we're generating 100 labels because we have 100 counties in our data set. So this is us defining the labels. Now it's actually very easy to add them in there. So we're just going to do label equals labels. Everything is getting separated by a comma when we add additional pieces. But now you can see that we're going over these different areas, and I can see that, okay, Nash County had 421 SIDS cases. I can now sort of look at like the ones that had the highest. So like Mecklenburg had 21,588 SIDS cases. Then we have Cumberland has 20,366 cases. And Guilford was another one that was have very, very high. So we get that information. You'll notice, let's zoom in a little bit. So what you'll notice about the label is that, okay, it's bolded. We've got the name of the county, and then we've got the number of births. But now we're sort of adding in, and somebody can be looking at that. So depending on like the county that someone is from, you might sort of want to look at it in more depth. So it's a really handy way to look at it. So we could look at, looks like Dare County for the Outer Banks, 521 SIDS cases. Okay, great. So we've added labels. We might also want to add a legend. So with our legend, we're going to want to specify the position. So in this case, I've just decided to put it in the bottom right, partly because in this map, in our bottom right, we just have the ocean. So I'm not going to be covering anything up. Then we're going to specify sort of like, okay, what was the palette we were using? So in this case, it was PAL 74. That was the kind of palette function we defined. Then we've got the values. So the values are going to be, we're including the tilde because it's like relating back to our data. And then we've got North Carolina births, 1974. We're using the $sign to reference the column there. And then we're going to add a title. So we've got like births by county, or like a better title would be like SIDS cases by county. And then we've got the opacity is 1. So that now when we look at the legend here, you can see sort of the different counts. So we can see like, you know, the ones that are from 20,000 to 25,000 are this sort of like darker red color. A lot of them, we can see that actually many of the counties have less than 5,000, which makes sense. When we were looking at our summary statistics, we could see that 3/4 had sort of less than 5,000 cases. Great, so that map is all set. I'm just going to quickly sort of go through the next one. So what I'd like you to do is put in the chat, we're going to create a second map of births in 1979. So we're going to need to create a new set of labels. So you want to, we can check the column names by using the function names in parentheses NC to check the column names. And then we're going to want to be changing NC $ births 1974 to the columns which correspond to the number of births in 1979. So I'll just give you guys a minute, and if you want to put in the chat when you've found which column we want to change that to, then let me know. But because it's just a second map, they're going to be sort of the same setup for those labels, but we are going to want to sort of refer to a different column. And while we're rating too, I would say actually to add to Fiona's bit about data for UK things, actually the ONS geography website is great. I can send around the link, but something like the Office for National Statistics has all of those official statistics. And as part of that, they would also have like the official geographic units for things. So something like that would be a really good one. So I would say that for any country, the national statistics offices would be a really good place also to look for that spatial information. Some of it is harder to find for different countries, or it's just not as sort of openly accessible on the web, but generally you can find sort of like a lot of the official data, especially because those national statistics offices are going to have to be running things like the census and other things. So they would have like a lot of information that's there. Yeah, so Jawad, the strong is just HTML for bold. So it's just for making it bold. So if we go back to this bit here, you can barely sort of see it, but you'll notice that Alexander is bolded, and then 1,333 births is not bold. So there's just, because ultimately actually what's Leaflet is creating is it's creating something that we can look at in HTML. So so we will use like HTML formatting for it. And I always find that the W3 schools website, they're a great reference for like a lot of free tutorials on things like HTML and other things, but you can just sort of cross-reference depending on what you would like. Mills, that's a really good question about whether you can use Sprint F to display a logo or flag. I think it might be possible because you could also, you might want to use something like, that makes me think kind of like an emoji or like an SVG image. But the honest answer is that I'm not sure. My guess would be that you might be able to kind of include some sort of like URL or image path, but I haven't done it before, so that would be a good one to check out. I have used labels to include like a website so that you can then have like a link that you can specify. But I think that some of them will sort of have different things. But yeah, my other thought would be maybe to look at like some of the emojis, and there's the icons package and also Font Awesome, which you can use to include emojis, which would also include some flags as well. Great, so we're going to create our second map. So we will have just wanted to specify, now instead of the births 1974 column, we're using the births 1979 column. So we would just update that. We would specify like our palette, if it's a little bit different. We're going to kind of keep everything else the same in terms of like the background, the zoom. What we're going to be eventually doing is putting these two maps side by side. So we've got the highlight options. We've also saved our labels into something called label 79, so that it's different from the previous one. So all of this is just the same as what we had before. We're just saving it into a new object called M2. Then we're also going to be adding our legend as well. So now we have two maps. We have M1 and M2. One of the nice things, so this is the M2, you can see actually that same counties where they were having a high number of SIDS cases, we can now see that Mecklenburg is actually at 30,757 births. And the Cumberland, so we're seeing sort of same counties. If we wanted to look at the change over time, we could actually take those columns and delete the later one from the next one. So then we could look at relative change in the number of cases, like have the number of SIDS cases dropped or gone down. In that case, that would be a good chance to use a diverging color palette, because we want to see sort of like, you know, which ones have decreased, which ones have increased. That could help us in some health decision making that we were going to make. So now we've got our two maps, M1 and M2, and then actually in LeafSync, this package, we can use the function sync. So whenever we want to be sort of more accurate with the functions we use, we can do package name : function name. And then we're specifying map 1, map 2. We're saying the number of columns. So in this case, I want it side by side, but you could do one like above and below. And then I'm doing sync equals all, so that now you can see I have these two ones. You can now see if I'm over here, so let's just get, what's cool is that, you know, if you zoom out on one, you zoom out on the other. And you can see the Cumberland County, it's then sort of showing me like the same sort of like area, so that I can be looking like down here, and then I can see the thing. The only annoying thing, at least as far as I know about LeafSync, is that ideally you would want it to have the label come up with Robeson 7889 births, and then the label coming up on the other one if you wanted to compare sort of like with like. But instead you just get sort of one and then the other. So it might be something that they, you know, that they might sort of be improving. A lot of these packages get updated and bugs get fixed, or people request sort of different features. So it might be neat, but it's really cool because you can sort of be like looking and comparing, and having this sort of ability to set things side by side can be extremely useful. And it's very straightforward. So you're just specifying like which map you want where, and then you can see those things. side by side. So something that might be interesting to look at in this case would be, you know, whereas these ones were quite low, I guess they've just gone above 5,000 in this case, but you could see sort of that these over here, you know, didn't used to be this darker tan color. So it can also sort of help you see if places are worsening or getting better. All of these things can be helpful. Okay, so those are the chloropleth maps, which are going to be really useful if we're showing something for a different administrative unit. So we could also be using like country or county or province or whatever the sort of different like geographic units are for a place. I also wanted to give a short example just of how we would use GPS locations, because oftentimes we'll get a lot of like point data as well. So some examples from my own research have been looking at sort of rabies cases. So I'd get the GPS location of where a fox with rabies was found. So I'd want to show that point on the map. Another example would be another research project I've done has been looking at gray seal movement off the coast of Nova Scotia. And then there again, it's like the seals actually have GPS tags on them. So each time they reach the surface, you would get like the location of where that seal was. So you may want to show set of points on a map. But another example could be like, you know, if you're looking at set of points of attraction within your country, or you know, locations that people would want to do it. Yeah, that's a really, really great point that Amanu raised, is that you could also put the label for both. So there's that thing stopping you from like having the label for the county and then actually putting the information for both. So you could actually see in both cases like what the births were. So you could have Cumberland, 20,366 cases in 1974, and then you could also include the information about 26,370 cases in 1979. So it'd be a good way to combine things. Great. So in terms of GPS locations, another common sort of data set that you'll have will be something where you have like a location associated with each of the rows. So in this case, I've got the location and then the institute, like different institutes around the world. And then I've got latitude and longitude associated with that. And then I've also got like an icon if you want to sort of customize like things for it. So this would be just an example of a different data set, but any sort of data set you have that has like a lat and a long column, you can also use to plot sort of using Leaflet. So if we're gonna make the Leaflet map, we'll be first sort of specifying our data set. So our new data set is called work. And then we've got add provider tiles. In this case, I've used Stamen watercolor. And then you can see I've also added a second layer because I want the Stamen.terrain labels. So you can't really see it here, but if I was to go and sort of scroll into main, you would see that I've got this watercolor background, but I've also still got those mountain labels. So even though they're not really like shown there, you can still sort of see that information. So for instance, if you were French and making or speak French and you wanted to make a map, you could use the French labels on top of things and then choose whatever background you would like. So there's some different options for what you want to do. And then add circle markers, you can think of that as being a different geom. In this case, we're showing locations. So we've got add circle markers, and then we've got, because it's relating to our data set and it's relating to a column, we've got the tilde LON for longitude, and then tilde lat for latitude. So again, if we go back to our data set, we've got the location, institute, work, lat, and long. So we're just specifying the names of those columns. So depending on your data set, your latitude and longitude column might have different names. Something that often comes up is you get like northing and easting. It'll be sort of different things, but that's giving us essentially the coordinates of where these locations are. And you can sort of zoom in on places to sort of see it. This is actually showing Sable Island off the coast of Nova Scotia. So you can actually see that it's a place as you zoom in, but you can see that the watercolor just makes things look very very nicely. Great, so we've got those. So if you want to find out about other things you can change about add circle markers, you can type question mark add control. And you can try adding cluster options equals marker cluster options parentheses. So you would just after the tilde lat, you could put a comma, and then you could put cluster options equals marker cluster options. And you can see what that does. So there's different things that you can specify. We're not going to go into as much depth on the different things you can change, but you can find out through the question mark add control different ways you could change what those points look like. So you may, for instance, want to choose to like make the radius of the circle, you know, bigger or smaller depending on different things. So you could look at say you were showing like location of earthquakes and like seismic activity, you could sort of make the radius bigger depending on what the level of things were. Yeah, so Isabella, that's an interesting question about like sending a specialist to a forest restoration site. I would think that it depends on how accurate Leaflet is. I think it could be useful, but you may want to stick something more with like yeah, sort of other ones. So I don't know if you could use it for like real-time GPS navigation. My feeling is that something like Google Maps or something else could be a bit better, just because Leaflet's only going to be as good and as accurate as some of the base layers that are on there. And I think that you could do something where it updates of the person's position, but I think it could be a little bit clunky. So I'm not sure if it would work. Yeah. Eldon, can you add a little bit more about your question? Okay, so let's go ahead and look at what we do when we add those cluster options. So the only thing I've added here is I've added that additional argument cluster options equals marker cluster options. Now you can see that what we have is that we've actually got sort of like the locations so that when you're zoomed out on a place, like I could like really zoom out and you can see, I mean, we can't really see places, but you could see that they're like, you click over that place, it's now showing you like a bigger area. So this can also be like a useful way if you're wanting to look at number of locations or number of sites and give people an idea of like, you know, which geographic areas have more. The cluster options can be like a nice way. And then as you zoom in, they'll sort of separate out. So now these are sort of two different locations. Or you can also click on them and then they'll zoom in and they'll separate out. So those are some useful ones. And then we can also add labels to our points. So in this case, I just actually want to add like the institute that is in that location. So we're just going to be using the %s. because it's going to be a character string. And then you'll notice here, I'm specifying a new column from that data set work. So I've got work $institute using the same sort of code where we're then using the lapply to make it into HTML labels. I've saved this into an object called labels. And then in this case, add circle markers actually takes the labels in this argument called pop-up. So what you'll notice here is we've got pop-up equals tilde labels, so that now when I click on somewhere, so for instance, I wanted to click here, we could see like the UFPR, which is in Curitiba in Brazil, or we could take a look at like Paraguay, and we can look at sort of different locations. So like the Instituto de Fomento Pesquero in Valparaiso in Chile. We can sort of look at like different places, and so now we also have like a name associated with those locations. Yeah, so Eldon, yeah, absolutely. So the only thing that you need is just a shape file that corresponds to the counties in the other countries. So the best places to find that information could be something like the National kind of Institute of Statistics in Kenya, or through something like QGIS or ArcGIS. There's some different sources that people often use for R. There's one that's like GADM, which is like Global Administrative Units. There's another one that I think is even more up to date and accurate. It's tricky because sometimes the most accurate spatial information is going to come from your country. But yeah, there's things like Africa Open Data. So you could look at like Kenya County shapefile. Some of the things is just that with updates, you know, if they redraw the lines or if they do things, it can be a little harder sometimes, like to get the information you want. And I don't cover it here, but what you would do is you'll often find the spatial information you want. So say it's on like the county level for Kenya. Then you'll have a separate data set that has something you've measured about each of those counties. So it could be sort of different sort of like, you know, statistics or counts. And what you're going to want to do is then you're going to want to join those data sets. So within R, you'll be using something like a left join or a full join or an inner join or a right join. Are like the common functions. And the bit of information that's the same in those cases is going to be like the county column that has the names of the counties. So if you have the names of the counties in one and the names of the counties in another, you can match those up. And then you're just forming a larger data set. And that's helping you get like the spatial information connected up. And that's often why they call spatial data like the great connector, because you can bring together sort of all these different data sets from different sources based on sort of one column that's in common. The tricky things there can be like, say the county name in one data set is listed in one language and listed differently in another. Or you can also encounter, sometimes there'll be like a small spelling mistake, or like there's multiple ways to spell things. So you'll often have to be like doing a little bit of the matching in your pre-processing in terms of changing the data. But otherwise, if you have that information, you can then sort of connect it up. And that's a really good way to sort of be doing it. Yeah, great question. Marcella, I'll definitely get to that. I just want to share with you guys a couple other resources. So RStudio has a great set of Leaflet tutorials, which includes similar information to this, but also some examples for like plotting rasters, more for plotting sort of like different types. There's also the Geocomputation with R book, which is another free open source book that's for some more advanced like geocomputation methods in R, but that can be especially useful depending on some of the things that you want to include. The other ones I'd recommend is that with my colleagues at AfriMapR, we've been putting together a series of like tutorials in Learn R. And so there's the AfriMapR like Intro to Spatial Data in R tutorial that's available. And there's one on getting data into R. So that can be especially useful if you're wanting to like load in your own data set. And then the other one is this joining spreadsheet data tutorial, which is the one I was speaking about in terms of you have spatial information, you have a data set, you then want to join them together, and it talks through a little bit of that process as well. Last thing I wanted to do, so Marcelo was asking about, so first of all, Asante Sana, thank you so much for joining. The slides are created by the R package Sharingen. So those allow sort of the web elements, and they work especially well for something like Leaflet. And Sharingen, it combines like remark.js, knitr, and also R Markdown. I also want to thank my colleague Richard Lation at the Data Science Campus, who gave feedback, and then also my student who's from Nairobi at Base College, Kamunto Angera, who helped me with some of the key Swahili. And then also the slides template was adapted from Garrick Adam Buey, and that's a sort of link to his GitHub page. And I'd welcome any questions.
Yeah, thank you so much, Dr. Laurie. This was amazing. We have learned quite a lot. Yeah, asante sana. Yeah, that means thank you to those who don't know Swahili. So any question is welcomed at this point. So we are past our time, but I'm sure Dr. Laurie will be willing to answer the questions. And then, so I don't see any question. Okay, in the meantime, in the meantime, you can stop sharing so that I share my screen and we can wrap up.
Mm-hmm.
Yes, the recording will be shared in our YouTube. Oh, Aurora has a question. He has raised his hand. Let me unmute. Okay, yes, please do unmute and ask your question.
Thank you very much, Dr. Laurie. It was very nice. Just one small question. This OpenStreetMap, is it to get the shape files also?
Yeah, so the OpenStreetMap just provides like a base layer. So the ones, you can choose it in the provider tiles, but you could also actually go to OpenStreetMap and also get spatial information from there if you would want to. So I think that they do get updated periodically. I'm not sure how often they're updated in Leaflet, like the provider tiles, but it's a really great open source like initiative, so that then you can get sort of like community contributed data and information about a place, which can add a lot of context depending on the map or the visualization that you want to create.
Thank you.
You're welcome.
Okay, once again, thank you so much to all the participants who joined us today, and also Dr. Laurie. This was so amazing. And someone has asked about where you can find the recording. The recording will be in our YouTube channel. However, immediately after we have done finished editing it, we will share with the participants. And so if you registered, you'll easily get it. But if you haven't gotten, in case it was shared, just send me an email, or you can send a chat on the Meetup page, and then I'll definitely share with you. So at this point, we can end here. In case you have any question, Dr. Laurie has shared with us social media account, so you can reach out to her and ask for further question or further explanation. So once again, happy holidays, and thank you so much for joining us, and we will see you next year. So our next meetup will be in January. So all the details will be shared with you. So yeah, enjoy your Christmas holiday, whatever that it is. Just have fun and see you in 2022. Feel free to leave.
Thank you all so much.
Thank you very much, everybody.
You're welcome.
You're welcome.